right, here is our lesson on differential equations. Get this pulled up. There we go. Okay, so differential equations are equations with derivatives inside of them. Weird. Yeah. So there's whole classes on this in college that like just differential equations, solving them. So we're not going to solve most of those ones. Right now, all we're doing is solving very simple ones where we can separate the variables. And then there's going to be two types of solutions we can find. And I'm going to draw you a picture to show you why there's two different types of solutions. So if you think about this function right here, this parabola, what is the derivative of this parabola? Let's say this is x squared plus 1. Well, the derivative is 2x, right? And that means that the slope at any given point is 2 times x, right? So the slope right here is 0. The slope right there, maybe it's 1. The slope right there is maybe negative 1. Well, what about this parabola? Let's pretend like it's the exact same width of a parabola. I didn't do a very good job at doing that, but there you go. So there's that parabola. What's the slope of that parabola? Let's say that parabola is x squared plus 4. Well, it's 2x, right? So the derivative, or the slopes of those, are going to be the same, right? Here's a slope of 0, here's a slope of 1, here's a slope of negative 1. So if I said the derivative of some function is 2x, what's the function? It could be x plus 2, or x squared plus 2, 1, gosh, or x squared plus 4. It could be either one of those, right? Because both of those would have the same slope, okay? So differential equations are going to have two types of solutions. The first one is the general solution, which says it's one of these functions. So like say it said, you know, the slope was 2x, then it could be this one, or it could be this one, or it could be this one, right? Because that's just, it could be x squared plus c, right? That's what that constant tells us, is that it's this function, it's the same function, it's just shifted somewhere else on the plane. And sometimes it's not just shifted up and down, sometimes it's shifted left and right and so on. The c changes different things, right? Or sometimes they're going to be asked for our particular solution. So first, this was the general solution. The general solution, and that's for things that we would have like a plus c, right? So we have this plus c, which tells us that it's one function, we just don't know exactly which one. Now the particular solution comes after we found the general solution, and we say, okay, we know it's one of these three parabolas, we just don't know which one. And then it says, well, we want the parabola that goes through the point 0, 0. So then the particular solution helps us find the exact function we're looking for, not just the general one. So it's going to give you like a point and say, okay, now I want the one that goes through such and such a point, and we're going to figure that out. Okay, so these are the steps to solving differential equations. First, we write y prime as dy dx because we're going to be doing something that looks a little bit like Mathemagic, but it's not too bad. Then we're going to separate the variables by multiplying both sides by dx, integrate both sides, and then solve for y. So we're trying to find a solution that makes it true. So here we have an equation. We're going to find the general solution of this equation. And it says x plus 2y y prime equals 0. So in other words, we're trying to find a function. Remember, our answer to a differential equation is a function, okay, or a family of functions. So we're trying to find the function that makes this true, that when I took x plus 2y and multiplied that by the derivative of this same function, I would get 0, okay? So the first thing we do is we rewrite y prime as dy dx. And then we separate the variables. So we get all the x's on one side and all the y's on the other. So we're going to end up with 2y. Let's make that smaller. 2y dy dx equals negative x. And then we multiply both sides by dx, or by dx, because see, dx goes with the x's and dy goes with the y's. And this is what feels like Mathemagic because there isn't we don't have the calculus right now to understand why this actually works, because up until now, dy dx has been this like, it's just a notation, right? But just believe me that we just don't have the calculus to explain it. We don't have the you don't have the math yet to explain it. It's just complicated, and it's not necessary to understand why we have to do this, but it can work. So we multiply both sides by dx.
Interruption, juniors and seniors that would like to visit with
Okay, so we end up with 2y dy negative x dx. Okay, so we're here, and now we have everything with a y, including dy on one side, everything with an x, including dx on the other side. Now, we need to find a function, right? And we have this, like, derivative. We have 2y dy, and we've seen something like this before, right? So we can integrate with respect to y on the left, and we can integrate with respect to x on the right, and it will give us a function. And our dy and our dx go away, right, when we integrate. So now we've separated our derivative, and we can integrate. So we're going to end up with 2y squared over 2 plus c equals negative x squared over 2 plus c. This is a different c, so let's call that c1 and c2. Now, what you might think is, okay, so that makes sense, but here's another little mathemagic thing. This c on the left, right, if I subtracted c1 from both sides, what would I end up with? Well, I'd have 2y squared over 2 equals negative 1/2 x squared plus a different constant, right? We could call it c3, because one constant minus another constant is just another constant, right? So when you're doing this, you don't actually have to write this c1 at all. Because in the end, we just have one constant. We don't need to have two separate constants, do we? So what we usually do is we just, by convention, put just a constant with the x. So in the end, this doesn't even have to be c3. This is just c. That's just c. Okay? Because a constant, doesn't matter if it's 100 or 1,000 or 1, minus another constant is still just a constant. So there we go. We have we've started this process, and we just need to have one c, not both of them. Okay, so then we simplify, and we end up with y squared equals negative 1/2 x squared plus c. And we're going to leave it like that for just a second, because you're going to see on the next page, there it is. Nope. It's just further down on this page somewhere. Aha! I almost missed it. Okay, write your solution to example 1 as a pair of possible functions, because this, right here, that's not actually a function, right? It's got a y squared in it. That's not a function. So we have to write it as two separate things, because, yeah, this would give us, for every x, there'd be more than one y. So we're going to take the square root of both sides. We're going to take the square root, and we're going to have y equals positive, or the positive side, negative 1/2 x squared plus c, and or y equals negative square root of negative 1/2 x squared plus c. So those are our two particular solutions, or those are our possible functions that we have in this case, because the y is all by itself. That makes it a function. Okay, now we're going to move to the next one. Find the equation of a function which contains the point 0, -3, and whose slope is that mess, okay, for each point on the curve. Okay, so we know the slope is equal to that, so that means dy dx equals x e to the x squared over y. So the first thing we want to do is we want to, if we had it written as y prime, we want to rewrite it as dy dx. And we're going to separate the variables. We're going to get all the y's on one side. So we're going to have y dy equals x e to the x squared dx. So now our variables are separated, so we're good there. So this was, I believe that's step 2 and 3. Hang on, let me grab that. Okay, so we have them separated. Now we're just going to have to integrate both sides. So we're going to take the integral of y dy equals the integral of x e to the x squared dx. Okay, and so on this side, this one's pretty easy. This is just y squared over 2 plus c. But again, we don't need to write it plus c because we're just going to write it on the one side. Now this one's a little bit more complicated because, you know, it's a function inside of a function and another function. So immediately I see a function inside of a function. I see x squared inside of e to the x, so that makes me think u substitution. So I'm going to call that x squared. Then du would be 2x dx, which makes dx du over 2x. So that makes a lot of sense because now I have e to the u over 2x du, and the x's are going to cancel out, and I end up with 1/2 times the integral of e to the u du. Okay, so I have that one integrated on that side already. And then I'm going to go ahead and integrate that. So we're going to just keep copying down everything I have. So I have 1/2, and then e to the u would be e to the u. So e to the x squared is our integral, and then plus c. Now we want to get y out by itself, so we multiply everything by 2. So I get y squared equals e to the x squared, because 1/2 times 2, and then plus 2 times c, but guess what? 2 times a constant, still a constant. So we're just going to call that c2. There you go. All right, so we get to there, and then we got to take the square root of both sides. So we get, let's make that so it's not behind my head, y equals negative square root e to the x squared plus c2, and y equals positive square root e to the x squared plus c2. Okay, and now I've already run out of room, and we haven't finished it because we've just found a general solution, but it says it has to go through the point 0, -3. Okay, well, which one of these would go through 0, -3? Well, that means y is negative, right? Y is -3. Okay, which one of these has a negative y? Well, this stuff underneath the radical always has to be positive, right? Because the square root of something, we're taking, you know, the square root of this. Well, e to anything is always positive. Anyway, it has to be positive, right, to take the square root of it. So which one of these is going to come out with a negative number? Well, this one, right? Because we take a positive number and then we multiply by a negative. So this equation right here is going to be our solution for a function that contains that point. So now, one last thing, we have to plug that point in to figure out what c is. Okay, so we have y equals -3, negative square root e, and x equals 0. Yeah, e to the 0 plus c. So we have -3 equals this negative square root, e to the 0 is 1 plus c. Okay, so we square both sides and we get 9 equals 1 plus c. And we subtract 1 from both sides and we get 8 equals c2. So c2 is actually 8. So we come all the way back up here and we take out c2 and we put in 8. And now we are done. That is the particular solution, not just the general solution. That tells us the exact function whose derivative meets the criteria we were looking for.